Right, here we have a slightly more complicated flow problem. So we have a cask that holds 1,000 gallons when full. It starts with 100 gallons of wine, which is 10% alcohol by volume, so 10 gallons of alcohol. And we start to feed in new wine at 2 gallons per hour. And somebody starts to, at the same time, flow out at 2/10 of a gallon per hour, assuming everything's well mixed. And we want to figure out what happens when the cask is full. Well, more to the point, we would like to just get something for how much alcohol is in it after T hours. So part A of the problem asks, what is the volume of wine after T hours? Well, that's going to be volume of T is going to be, we start with 100. The inflow is 2 gallons per hour, so that's going to be 2 times T. And then we're subtracting out 2/10 of a gallon from the outflow. So that gives us 100 minus 1.8 T. Okay. B asks how long until the cask is full. So how long until full? Well, that's just going to set the volume, which we know is 100, minus 1 point. I'm sorry, this should have been a plus here. I don't know what I was thinking. Plus 1.8 T, and I want that to be 1,000. So that's going to be 1.8 T equals 900. So the time until we're full is 900 over 1.8, which turns out to be 500 hours. So, okay, part C then is what's the concentration of alcohol in the vat after T hours? So the concentration, well, that is amount over volume. In this case, that is, the amount is just what we're calling W, and the volume we've just decided is 100 plus 1.8 T. So there's our concentration. Okay, this is actually a different order than in the problems in the here. That's the concentration. This is what was D. C is the rate in. Well, that is the rate the alcohol is coming in is we have it coming in at the total volume of liquid coming in is 2 gallons per hour, and the concentration is 15% or 0.15 gallons of alcohol over for each gallon of wine. So that's going to be 2 times 0.15 is 0.3 gallons per hour. So D, let's see, D I've already, yeah, I'm not doing these in order. Let's see, so E is the rate out. Well, that's the flow rate again. So the flow rate is 0.2. That's gallons per hour. And then the concentration is, we've decided, is W over 100 plus 1.8 T, which is not much I can do with that. That's just going to be 0.2 W over 100 plus 1.8 T. All right, so we now want to get a differential equation and solve it. So that is going to be dW dt is rate in minus rate out, which is 0.3 minus 0.2 W over 100 plus 1.8 T. Yet again, this is going to be a first order linear. So this is W prime plus 0.2 over 100 plus 1.8 T is 0.3. So the integrating factor is e to the integral of 0.2 over 100 plus 1.8 T dt, which is e to the 0.2, then I get 100 plus 1.8 times T, and I have to divide that by 1.8, the chain rule. This turns out to be what? E 0.2 over 1.8 is just 1/9, the natural log of 100 plus 1.8 T. And by rules of logarithms, this is just 100 plus 1.8 T to 1/9 power. All right, so let's rewrite our equation. What was that? That was W prime plus 0.2 times 100 plus 0.8 T I'm sorry, I have that miscopying there. 100 over 0.2 over 100 plus 1.8 TW, and that was 0.3. When we multiply through by the integrating factor, it's going to become 100 plus 1.8 T to the 1/9 times W, that whole thing prime, times 0.3 times 100 plus 1.8 T to the 1/9. So I can integrate this and have 100 plus 1.8 T to the 1/9 power W is 0.3 integral 100 plus 1.8 t to the 1/9 dt. Yeah. Which is okay, so I still have my 0.3 there. When I integrate this, I'm going to have a 100 plus 1.8 t. The exponent is going to go up by 1, so t over 9. So I'm going to take the derivative. I need to cancel that out, so there's 9/10. And I also have a 1.8 here. That's going to cancel this out by the chain rule. And you do a bit of arithmetic here, and this is 0.15 times 100 plus 1.8 t to the 10 over 9 plus c. And now I'm going to divide by this. Note that this 10/9 is exactly 1 bigger than 1/9. So that when I subtract, or I divide, what I'm going to get is W equals 0.15 times just 100 times 1.8 t to the just 1 power plus c times 100 plus 1.8 t to the minus 1/9. Now, so we're almost there. W of 0 is 0.15 times 100, putting 0 in there, plus c times 100 to the minus, let me neaten that up a bit, to the minus 1/9, and that is equal to 10. So c is equal to, let's see, 10 minus 15, okay, 100 times 1.5 is 15, divided by, no, I take that back. Oh, I guess I could write it that way. Let me do that. Divided by 100 to the minus 1/9. And if you do that, that turns out to be minus 8.34050. So we finally have W of t is 0.15 times 100 plus 1.8 t minus 8.34050 times 100 plus 1.8 t to the minus 1/9. And one of the things the problem asked was, what is the total amount of alcohol when it's full? So that's just asking for W of 500, and that turns out to be, if you just plug it in there, turns out to be, what was it, 14.129. Let me write that a little more readably. 14 point 129. Okay, and that is enough, and probably more than enough.